Dear students, today we will discuss operating system. Operating system is one of the core subject of computer science engineering. Basically, without operating system, it is uh, the other way around, can't do anything on the system, right? So when you switch on the computer, what happens exactly? The operating system is going to be get loaded from the hard drive to the main memory rather, right? So there is a bootstrap loader program which you find in the lower part of the in the ROM of the system, which is going to be get executed. So what happens when you switch on the computer is the program counter register, which holds the address of the next instruction to be executed, will be made to point to the beginning of the bootstrap loader program, so that CPU can start executing the bootstrap loader program. Once the bootstrap loader program start executing, then the operating system programs are going to be get loaded from the hard drive to the main memory. So once they are loaded, they are in the form of DLL and EHC, ready to provide the services, different kind of services that operating system provides, starting from resource allocator. It provides the resources to all the processes that are running on the system, that are that are willing to complete their job, and process management, file management, disk management, memory management, all these different kind of services that it provides with the help of the DLL and EXE files that are running in the background. So the processes which are running in the background, we even call it as a daemon processes. So these processes are going to help us in getting our tasks done. Fine. Let us look at process management. What is a process? Process is a program under execution, rather, right? So what happens when you have the multiple processes running, right? So multitask operating system, like for example, Windows time sharing operating system like Linux, wherein you have the process management being taken care by the operating system, right? So when probably all the jobs are being submitted, so once it is created, right? So it is in the start state, then they will be submitted to a ready queue. So all these processes who are willing to finish the job, they will be put into the ready queue. Then based on certain algorithms, like what we call it as scheduling algorithms. So different kind of scheduling algorithms, CPU scheduling algorithms such as FCFS, first come first serve, shortest job first, and we have round robin priority algorithms, right? So these are some of the well-known algorithms. Round robin is one which is being used in Linux or Unix, okay? With the help of which you could able to implement that time sharing of the same, right? So what happens here when the jobs are put into the ready queue, based on the scheduling algorithm, dispatcher will dispatch one of the process and schedule it for CPU, so that the CPU can start executing that particular job. So when the job is being executed under the CPU, we say it is a running state, right? So after it finishes the execution, it will go to the exit state. So, but otherwise, sometimes what happens, like for example, in round robin kind of our time sharing operating system like Linux, where there is a equal time quanta is going to be given for each process. So once the time quanta of the process is finished, it will put back into the ready queue by making it to wait for the next turn. So that after once it gets the next turn, only then it can go for the further execution, right? Until it will not complete its execution, it will be after every turn will be put back into the ready queue. That way, the execution of that particular process in round robin or time sharing operation does. Okay. And similarly, while the process is in execution, sometimes what happens is while in execution, there is a possibility that a process may require some input from the keyboard, or it may be waiting for some kind of event. Then in such situation, what happens is it gets blocked or get into sleep method, or probably waiting for that event. Then that happens, it's being suspended for a while. So we say it is a block state, right? So and then once that event is done with, or once the sleeping time is over, it will resume back and then can go back again to the running state, right? So that way the execution of the processes will happen until execution of the processes happen. So that's going to be under running mode, right? So this is the life cycle of the processes. Okay. So based on the different kind of scheduling algorithms, the operating system will take care of executing the different processes with their job to be done. Okay. Similarly, file management is another kind of service that it provides. Different how the allocation of the memory for file is going to be done, right? Based on different kind of methods we have, like we have linked allocation, we have index allocation, we have grouping kind of thing. Okay, so these are some of the methods with the help of which the file management will be taken care. And the disk management, when the disk has to be revolved, and then and our required file has to be brought under the head of that particular. We have different kind of disk schedule algorithm like scan, cscan, and look, clook and all, right? So with the help of these algorithms, it will provide the different kind of services under disk management. Similarly, memory management, when the memory is required for a particular process is brought into the brought in for execution. Basically, the entire memory is going to be divided into equal number of blocks that are said to be pages, and these pages are required to be brought into the main memory, for which if there is no space available on that main memory, one of the page has to be victimized, which is already available on the main memory, for which there are some page replacement algorithms are going to be used. Okay, such as LRU, MRU, and optimal and all. So these are some of the a couple of algorithms which are being used as part of memory management in order to let the different processes, as and when they are required to be brought into the main memory, providing the memory for it, and then let it to be executed to the fullest. So this is and this is allocated, as I said, whenever a particular process require a particular resource like input device or memory or CPU or that kind of thing, they can be made available by the operating system. Okay, that's the reason why we say it's resource allocated. These are all different topics that we are going to discuss in operating system. So this is just of operating system what we have discussed today. So the detail of the same will be followed in the subsequent classes. Okay, thank you.